Okay, let's talk about lists and data frames. So I'll go over the assignment for this week, and so a couple students have asked some questions. Thought it would be best just to make a quick video to show you this. Um, the introductory scripts are here. The sample CSV, some folks have had trouble downloading that. It's the same sample CSV that we had in the previous example, the sample.txt, that same set of records. It's the same for this too as well. So here are the questions right here. Create a list that has three fields: ID, category, v input. Populate it with 100 records. Then create a function that'll take v input, that field that you created, the Boolean field. Set it to true if the value is odd, or false if the value is even. Straight up. That's pretty simple. Execute a function will scan through a file to determine word frequencies. Use a bar plot to display the results. There's probably 5 different ways that you could solve for this one. Use a read CSV to read in the sample CSV into a data frame. And then create a simple linear regression. So now the pieces of this that'll probably give you the most trouble. First of all, understanding a list. If you didn't get that from the introductory video, I'll show you a different example. Maybe that'll make it a little bit more clear. The recode, that's what simply is what you're doing here with the v input. We did a recode last week, so that should be relatively straightforward for you. The word frequency, there you can use, there's a function that's inside the book. If you use that, then you'll want to do the comments, each line, what's going on in each of those lines. If you want to use the Quanteda library, then you don't have to do that. And I'm going to show you a bit of Quanteda here in a second. Read CSV, we've done that in a previous example, and then the simple linear regression, that one causes a little bit of difficulty too. So let me go here. Oops. Let me go to R real quick. Okay, so here's your R right here, and for the student that was having some trouble with the console, let me expand out the console. Let me make sure that the plot pane is big too. Okay. And let me just clear the deck to make sure that all of our tabs are clear. So there. Fresh. First of all, let's create a list using the list keyword. I'm going to use different variable names and different things in my example. That will kind of make it clear. If you just copy this and submit it as your own, you're not going to get any points. I want you to do it, again, the way that the assignment, create an ID, create a category, and create a v input for the 3 fields that you're going to have inside of your list. Okay? In my case, I'm going to create something called wacky ID. I'm going to create something called blue turtles, and I'm going to call a Boolean input of true or false is what I'm going to make here. So in order to do that, you use the list keyword, put the 3 fields. Now this is going to create the first record inside of your list. But then if I wanted to populate it, in my case, I'm going to populate it with 500 records. For your case, you'll want to populate it with 100. Now here's the thing. With lists, you have to make sure that if you're adding elements to the list, that you stay within whatever the top element of that list is. So right here, the very first thing I'm going to do, I'm going to use a sequence keyword. By using sequence, it's just going to basically generate a sequential sequence from 1 to 500. That's all that statement's going to do right there. By using these bracket notations right here, it's going to go back to the ID that I have up here. So let's say right here, instead of ID, I'm going to say, okay, and instead of category, I'm going to say, and instead of v input, now let's just try the list piece of it by itself. First of all, let me create the list. And you'll see over here I've got a test list. It's got wacky ID, it's got blue turtles, and it's got the Boolean input. I'm then going to create a sequence of 1 to 500. I'm then going to use the replicate function. And I've given 5 different things here: red, blue, green, orange, yellow. You'll want to use something else, obviously. But for my blue turtles, I'm going to have those individual colors there. That would be very similar to what you could do for your categories. And then the bool input, I'm just going to have random true, false, true, false, true, false. Since I'm going to use 500, I have 5 different categories here and 5 different booleans here. So I want to use 100. 100 times 5, that gets you 500. If you try to put in 600 in that, you're going to get an overflow error, subscript out of range error. So let's give this a try. And I don't have any red down here. It looks like, yes, I do have good data right here, so that is fantastic. And if I view the test list right here, we can see that it's fully populated. Check. That's the item for that one. Now to populate, this is going to be, again, just a simple replacement. So this is very similar to the recode that we did last time. So what you would do if you're going to use this function right here, you'll want to go ahead and put comments to what each of these are. The only new introduced piece of this is going to be this double percent sign, and that's the modulus operator. So again, since it's asking about true or false, what you can do is you can do a division by 2. So a modulus 2 will divide it by 2. And if it equals 0, then that means whatever number you have is divisible by 2, i.e. it's a even number. So that's the reason why you can use that little math trick in order to do that piece of it. But what you'll do is you'll explain what's happening inside this function if you're going to use this. There's alternate ways, and there's actually a way that you could do this with one statement. So if you use those, that is good as well. And then have some test statements after that. The next one is going to use do a scan through the file and look for word frequencies. So one of the ways which you can do this is the way that was presented in the book. The other way you could do this is with something called Quanteda. Quanteda. So Quanteda.io gets you to this site right here. Under their Quick Start Guide, there's a Quick Start Guide right here. That gives you everything you need to know. First of all, you'll want to install the package Quanteda. And then call the library. We've done this in the previous week of calling libraries. Read text is an easy way to read a text file in. And then from that, here's how you create a corpus. Here's how you do a summary on it. Here's how you do a plot on it. Now, let me show you the example right here. So here I'm installing the package. I've already got it installed on my machine. I can just call Quanteda. But let me go ahead and run through both of these 2 steps right here. Okay, we can see that it's installed the package. It's loaded the package right here. There are some warnings, again, because of the version that I'm using, my version of R that I'm using. I've got some warnings, but it's not going to affect the bottom line of this. These examples come straight off the Quanteda page. So if you were here in the Quick Start and you're going through this Quick Start, these are the exact same things that appear here. You will obviously want to replace this with your data file that you read in. So here, as you did the read text, that corpus would be off of the text that you read in, not the data character for UK immigration. But let me just show you how this works. This first statement right here builds a corpus, and the second one does a summary on it. A corpus is nothing more than a collection of documents. And so it could read in one text, it could read in multiple texts, and that's all part of what this is. By running the corpus command and then by running the summary command, it automatically does the tokenization for you right here. And so we know how many tokens are, how many individual words that they have, how many sentences, etc. That's all broken out as part of that summary. So then it simply becomes doing a bar plot. So in the assignment, it asks you to do a bar plot. Here's a bar plot example for this one. Oops. Sorry, I didn't define it right here. And now we've got the corpus is defined here. We can see the token info is defined here. If I browse the token info, I can see it's got some text right here. This is presidents, it looks like. It's got some types. It's got some tokens, sentences, year, president, etc. Now we did do the docvar right here to identify what the year is. That's part of the demonstration that's on Quanteda. That's not required for your particular assignment. But then it turns around and it does a nice little ggplot. So if you want to see what a nice pretty one looks like in ggplot, there's an example right there, showing basically how many references within a given year that you're going to see within that. But if we just do a simple bar plot right here of the tokens, this is really what you need to do for the assignment. It just gives you a simple histogram showing you. So that's one of the ways that you could solve for the word frequency question. Please, please, please do not use this data set that I'm using here. This is simply for an example. You should use the data set that you load in. Okay, finally, the simple linear regression. And I gave you an example of a linear regression before on this one, but let me run you through another one. I'm going to load the lattice library to make this a little easier on myself. And then I'm going to look and see if we have linear relationships. I'll go ahead and clear these off for you. So let's do a simple scatter plot. We can see generally we are seeing a linear relationship right there. Then let's do a scatter plot and break it on the species. So broken by species, we can see where each individual species is at within that. And so here's the actual command to create the linear regression. So it's the LM command, and you're going to compare the length to the width, and the data set I'm going to use is the iris data set. Now remember, from the instructions, it says orange trees. So if you turn in one with the iris, I'll know that you've just copied this and you didn't actually try to do it on your own. So make sure that you use the orange tree data set and not the iris data set, or you will get no points. That built out the simple regression, the regression line. We can then turn around and plot that. So here's your original petal length versus width. Let's go ahead and overlay a line and let's print a summary. So overlaying the regression line on top of it and looking at the summary right here, we can see that the significance codes to the 2 standard deviations looking pretty good. Now let's look at one with a poor relationship. That was a good relationship. Let's look at one with a poor relationship. I'll go through the exact same stages here. And now if we look here, we see a completely different result out of it. The linear regression line still draws, but just visually looking at the scatter plot, you can tell that it's not a good linear type relationship compared to what we had saw in this previous plot right here. This is clearly a linear relationship. That is the assignment. That is the question for the linear relationship, for the linear regression piece of it. So you'll want to do all of those steps, plus also read in the CSV, which you had an example on a previous week on. So hopefully that helps answer some of those questions which were circling around out there. Again, apologies. I was not feeling up a little bit under the weather yesterday, and so I was not able to make office hours. There will be an office hours tomorrow in order to make up for it. And obviously, if you have any other questions, please just reach out. Have a good one. Thank you.